Go buy yourself a good pair of rain boots and start stocking up on food, because a Godzilla El Niño might be on the way. If it really happens, parts of the southern United States and southern Europe could soon be hit by intense rainfall and face a much higher risk of flooding. The same goes for South America. A series of catastrophic rainstorms could flood roads and trigger huge mudslides in countries like Peru and Ecuador. While some places deal with too much rain, others may get none at all. Indonesia and Australia, for example, might experience severe drought, which could cause massive wildfires and wipe out their water supplies. Experts think El Niño could happen sometime between June and August of 2026 and stick around until the end of the year. There's even a 1 in 3 chance it could turn into a super El Niño by late fall. I mean a really intense, catastrophic version of this event that's also known as the Godzilla El Niño. The problem is, even if you're in part of the world that isn't directly affected by this phenomenon, you might see its consequences anyway. Because it can ruin crops and cause global food shortages. That makes your everyday groceries like rice, coffee, and sugar way more expensive. No one wants that, but it's not like we can avoid El Niño. It's just a natural part of Earth's climate that's been happening for millions of years. It all starts in the Pacific Ocean. And since this ocean is so huge, whatever happens there kind of ripples across the whole planet. You see, under normal climate conditions, tropical winds blow west along the equator, pushing warm surface water from South America toward Asia. As that warm water moves away, cold water rises up from the deep ocean to take its place. We call this process upwelling. But the Earth always likes to surprise us, right? So, from time to time, a cycle known as ENSO shows up and breaks those rules. This natural cycle is divided into 3 phases: La Niña, El Niño, and an in-between stage where things are relatively quiet, known as ENSO neutral. La Niña is the cold phase. When it happens, those tropical winds get even stronger than usual, shoving more warm water toward Asia. Near the Americas, super cold water from the deep ocean rushes up to the surface. This shifts the jet stream, those high-altitude winds that steer our weather further north. For the US, a La Niña year usually means a warmer, drier south and a much colder, rainier north. It also tends to make hurricane seasons in the Atlantic way more active and dangerous. El Niño is the exact opposite. It is the hot phase. This is when the tropical winds weaken or even reverse. The sea surface temperatures can reach 9 degrees Fahrenheit above their normal levels. Instead of being pushed away, all that warm water flows back east toward the Americas. This pulls the jet stream way south of where it usually is, and that changes the weather completely. Areas in the northern US and Canada stay warmer and drier than usual, while the southeast and the Gulf Coast get soaked with constant rain and flooding. El Niño and La Niña episodes tend to happen every 3 to 7 years, with each phase usually sticking around for about a year. But don't expect a fixed schedule. It happens. At the beginning of 2026, the world is watching it all unfold again. A weak La Niña is finally fading away, and little by little, it's turning into an El Niño. And experts think it could be a massive one. All the signs from the ocean and the atmosphere show a powerful El Niño pattern picking up speed as we head toward the fall. If the water keeps warming up at this rate, some meteorologists believe this event could become exceptionally strong. A super El Niño is on a whole different level. It happens when the Pacific gets so warm that it basically throws the world's weather off balance. This can lead to much more extreme weather shifts. Instead of just a little more rain, you get massive floods. Instead of a short period of dry weather, you get a serious drought. This event also pushes storms into places they don't normally go, and that ends up affecting the whole world. If you're not a big fan of summer, I have bad news. A new Godzilla El Niño is probably going to push global temperatures to record-breaking heights. It's going to be unbearably hot. The last time the world had to deal with a super El Niño was back in 2015. That year, the water in the Pacific got incredibly hot, and that set off a chain reaction of disasters around the globe. The hurricane season was unlike anything we'd ever seen. Usually we see 4 or 5 tropical cyclones in the Pacific. But in 2015, there were 16. That's insane. At one point, 3 massive Category 4 hurricanes named Kilo, Ignacio, and Jimena were all spinning at the exact same time out at sea. That was a first since we started keeping track. Luckily, none of them actually hit land. But we weren't always that lucky. In July 2015, Hurricane Dolores sent record-breaking rain into Southern California, causing over $50 million in damage. Later that same year, Hurricane Marty hit the coast of Mexico, leading to another $30 million in losses. South America was hit with way more rain than usual. Rivers in Argentina and Paraguay overflowed, forcing thousands of people to evacuate. Because of El Niño, 2015 became the hottest year on record at that time, and it brought terrible droughts. In Ethiopia, for example, some parts of the country got less than a third of their usual rain. Crops failed big time, and over 8 million people were left without enough food. So, are we going to face something that intense again? Well, it's hard to say. Most experts agree that an El Niño is in fact coming, but we're still not sure about its strength. Early data shows everything from a weak event to a record-breaking Super El Niño. Scientists are watching it closely, but they need a few more months to see how it actually behaves. The El Niño is expected to show up by summer. Usually we don't feel the effects right away, but since this one is moving so fast, we might start seeing weird weather sooner than usual. One big change we can expect has to do with the Atlantic hurricane season, and that's good news for the US. Usually, the El Niño lowers the overall numbers of hurricanes in the Atlantic. That's because it creates high air pressure and stronger winds high up in the sky that basically rip the storms apart before they can grow. In this part of the US, this makes the whole atmosphere more stable, which stops small storms from powering up into giant hurricanes. But the main impact of El Niño usually happens in winter, and it messes with the snow. If you live in the northern US or the Midwest, you will probably see a lot less snow than usual. Of course, these are all just predictions based on what happened in previous years, but it's not a perfect science. After all, we never see the exact same weather 2 years in a row, and when you throw an El Niño into the mix, things get even more unpredictable. One thing's for sure. Since this phenomenon affects millions of people, experts have to keep a close eye on it every year. Seasonal forecasts for El Niño and La Niña too show how the weather is likely to change, helping authorities plan ahead for energy and water needs. This way, cities can prepare for too much rain or severe drought, and farmers know what to expect for their crops. But most importantly, weather alerts let people find shelters and get communities ready before disasters hit, and that saves lives.
We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to Southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the Enso cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication, both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside. If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain, and that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister. and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable, and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters, but areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
The ear-piercing sound of sirens brings your relaxing Saturday afternoon to a screeching halt. You jump out of the chair and run to the window. The sky is covered in black clouds all the way down to the horizon. The trees are nearly bent over flat from the gale-force winds. Together with the rain, golf ball-sized hail crashes into the ground, on rooftops, on parked cars. It sounds like a stampede right over your head. Car alarms are going off everywhere. Just then, crack! Huge bolts of lightning flash across the black sky. Then the monstrous grumble of thunder. Your heart jumps in your throat. As you peer through the window at the sudden chaos outside, you're filled with a primal fear of the power of nature. You snap back to reality. The sirens! Gotta get to the basement! You start to turn away from the window, and that's when you see it. A massive tornado ripping along the city street. It's throwing entire motorcycles, refrigerators, and even trees like baseballs. The roof of that building starts peeling off like a Band-Aid. The twister even lifts cars and pieces of asphalt as if they're made of feathers. It seems this tornado will flatten your city within an hour tops. You finally snap out of your hypnosis and run to the basement. The sound of the city being ripped apart terrifies you as you hunker down below as low as you can. But after about 20 minutes, everything is suddenly silent. You head out to see the clouds have disappeared, and the sun's rays illuminate the street. Luckily, your house was spared, but your modern city now looks more like ancient ruins. Stop. Tornadoes never come into cities, right? Yeah, they do. This monster doesn't care where it goes and what it eats along the way. While we're at it, you can forget about the myth that tornadoes will magically stop when they meet rivers, lakes, or mountains. They just keep on going. But about that no twisters in the city thing, about 1,000 tornadoes hit the US each year. That's 75% of all the tornadoes in the world. Most of these monsters occur in a strip, okay, more like a long blob, running up and down through the middle of the country. It's an area aptly dubbed Tornado Alley, a perfect spot for these things to form. You get cold, dry air coming down from Canada, meeting warm, humid air traveling north from the Gulf of Mexico. Warm air is less dense than cold air, so it rises and creates a strong updraft. Water droplets surround it to create the funnel cloud. There you go, recipe for a tornado. Now, if you closed your eyes, spun around, and put your finger on a map of the US, the chances of your finger landing on a major city are pretty slim. If you gathered all the cities in the whole country into one area, it would only be 3% of the US's entire land. Just like your finger, the likelihood of a tornado striking in the city is much smaller than landing in a rural area. When it comes down to it, tornadoes can touch down in big cities. They just hardly ever do, thanks to sheer chance. Another surprising myth. You always see a tornado coming because, funnel cloud right ahead. Not true. The approaching funnel can be completely camouflaged in a wall of rain. You might finally see it when it's right on top of you. In this case, you'd better trust your hearing. First, tornado warning sirens go off if you're in a place that has them. Second, listen for a loud rumble that sounds like a train coming. That's a sure sign this beast is somewhere nearby. Many people immediately start heading for shelter when they see green clouds in the sky, because we all believe it's the #1 sign of a tornado coming. Don't buy it. Yes, a green sky is a sign of a severe thunderstorm that's powerful enough to produce tornadoes, but it's not a guarantee like many people see it. While we're at it, you know how movies show the ground ripping apart during earthquakes? The gaping hole that swallows cars, houses, entire cities? Not a shred of truth to this. A crack may appear in the ground with major earthquakes, but it rarely exceeds a couple feet wide. One of the most overspread myths out there is that lightning will never strike the same place twice. Tell that to the Empire State Building. It gets hit by bolts of lightning at least 25 times a year. Pretty sure nobody's picking the building up and moving it to different locations. Yes, lightning likes really tall things, and it's not shy to keep coming back. As for that old warning about your cell phone or jewelry attracting lightning, busted. There hasn't been any scientific support for the idea that personal objects with metal in them attract lightning. You still shouldn't be out and about during a storm though, cell phone in hand or not. Now, if you're looking for a tsunami and only focused on giant walls of water, you might never see one, even if it's right in front of you. Tsunamis aren't always massive tidal waves crashing into the shore. More often than not, they look like the tide is rising extremely rapidly, receding and rising again until it overspills into the city. Not that tsunamis never form walls of water, it's just not as common. Picture Earth. Are you imagining a perfect ball? Well, to resemble the truth more, squash the poles down a little. There, now you have a realistic Earth. Scientists call the Earth an irregular sphere, or ellipsoid in fancy terms. The planet rotates on its axis, causing the equator to bulge out a bit, just like what happens when you spin fast on a merry-go-round. You feel pulled out and away from the center. What's the highest point on Earth? Everest, of course. But if we go from the point furthest away from the center of the Earth, the crown goes to Mount Chimborazo in the Andes. Its peak is actually 6,800 feet closer to space than the summit of Everest. That's because Chimborazo sits near the equator, where the planet's bulge is greatest. The blue whale weighs as much as 30 elephants, makes sounds louder than a jet, and eats 4 tons of food every day. It's the largest living creature this planet has ever seen. Only, not technically. Head to the Malheur National Forest in Oregon, home to a creature that weighs as much as 20 blue whales. The honey mushroom is a humongous fungus colony united into a common system. The giant covers an area of 1,500 football fields, and it's thousands of years old. Ask anyone to draw the sun, and they'll draw a happy yellow circle. But if you look at our star from the moon or the International Space Station, you'll see that it's actually white. From Earth, the sun looks yellow or red thanks to the atmosphere acting like a filter. Most people think time is constant and moves at the same speed no matter where you are. But the speed of time depends on how close the watch is to Earth. The weaker the gravity, the faster time passes. So the person living in the apartment above you is aging faster than you. Now, it's only 90 billionths of a second faster per 1 foot higher, so don't expect to notice a difference if you decide to move to the first floor. The ground under your feet feels pretty solid and whole, but in reality, the Earth's crust is all broken up into plates surfing on oceans of liquid rock called magma. You don't feel it, but the ground under you is moving a little over ½ an inch per year. That's about the same rate your toenails grow. Largest desert in the world? Easy, the Sahara. Nope, it's Antarctica, which is almost 2 times bigger than the Sahara. A desert isn't just a scorching sandy place where it doesn't rain. It's a place with very little precipitation, so that includes snow too. In some parts of Antarctica, it hasn't rained or snowed for millions of years. In other parts, snow does fall, though rarely. Point is, there's a myth that it doesn't snow in extreme cold. Antarctica is the coldest place on Earth, and it snows there. There is some truth to this old saying. Cold is drier. It doesn't retain moisture as well. You need moisture to produce raindrops and snowflakes. That's why there are fewer chances for snowfall when temperatures drop so low.
Welcome to the Spirit of Discovery cruise ship, which will take you on an unforgettable sea voyage around the Canary Islands. The azure endless ocean, delicious food, the highest service, premium cabins, and a terrible nightmare. that you will probably remember for the rest of your life. This is exactly how one luxury trip of the Saga Cruises Company ended last year. Instead of relaxing during the cruise, passengers felt fear and horror, and even had health problems. And that's why. On October 24th, the Spirit of Discovery liner started a 2-week cruise around the Canary Islands. There were about 1,500 people on board. About 1,000 were passengers, and the rest were crew members. The first week went great, but then the liner encountered a serious problem called nature. There were strong winds and big waves. The captain decided to return to the UK ahead of time, but the decision was made too late. The ship was caught in a severe storm in the Bay of Biscay. A powerful wind with a force of 11 points hit the vessel. To make it easier for you to understand, the 11-point wind is able to tear out trees together with roots, destroy residential buildings, and plunge entire cities into chaos. Such a storm is rare, but Spirit of Discovery was unlucky enough to get into its epicenter. 11 points is the penultimate place on the Beaufort scale, which determines the wind rating. The most powerful storm has 12 points, and this is a hurricane. The wind reached a speed of 65 miles per hour, which is about the same as the average speed of a car on a highway. Not only did it push the Spirit of Discovery, but it also raised huge waves 25 feet high. Just imagine a wall of water the height of a 3-story building collapsing on a lone ocean liner. At that moment, the captain sent a message to all the passengers through the cabin speakers so that no one left their place. And his voice sounded worried enough. All the passengers had to lie down and hold on tight. According to the witnesses' words, the ship remained caught in the storm for about 15 hours. They held on with all their might so as not to crash into the walls and floor. All this time, tables were flying around the ship, dishes were breaking, furniture was moving all over the cabins. The waves smashed windows, partitions, and doors. Some people were knocked down because they couldn't hold on for so long. The storm hurled the passengers from ceiling to floor, from wall to wall. The ship's crew turned the dining room into a medical area to provide assistance to those who had been hurt. Despite the difficult and terrible conditions, the ship's team did a great job. They regularly informed passengers about the current situation and tried to calm everyone down. There was no panic and chaos on board. When the storm finally ended, the ship continued its journey and finally reached land, where medics urgently evacuated 8 passengers to the hospital. One of them was never able to survive this storm. It's good the ship didn't meet a rogue wave during the storm. This is a natural phenomenon that can appear during a storm and even in still water. It's a giant wave with a height of 60 feet. Like a 6-story house, it collapses onto a ship with incredible speed and capsizes it. And then the wave suddenly disappears. This is no joke. A similar wave has been recorded in the Gulf Stream off of Charleston, South Carolina. It's scary to get in its way. Now, let's go back to the past to remember one of the most terrible maritime tragedies. No, we're not talking about the Titanic. We'll talk about the Greek liner Laconia, which set sail from the English port of Southampton on December 19, 1963, with more than 600 people on board. However, just 3 days later, a terrible tragedy happened to the ship in the boundless waters of the Atlantic. At 11 p.m., in the barbershop hall, an electrical malfunction occurred. The problem led to a fire, which quickly spread to other rooms. The crew couldn't cope with it, since the fire was spreading too fast. The ship's team turned on the fire alarm, but there was no command to leave the vessel. Only 2 hours later, the captain ordered the passengers to evacuate. All this time, people were either relaxing in their cabins or enjoying a party in the ballroom. The crew was probably trying to put out the fire without causing panic. However, when the situation became critical, the evacuation began. People panicked and ran to the lifeboats, but many didn't manage to get inside. One of them was John Morris. He survived this catastrophe and shared his memories of how he put his family in a lifeboat while he stayed on board the ship. He didn't even have a life jacket. Since there was nowhere to go, the ship's crew opened a bar so that people could relax a little. However, at that moment, boilers began to explode inside the ship, and it became clear the vessel wouldn't stay afloat for too long. John Morris decided to jump into the water right in his tuxedo. As soon as he was overboard, he grabbed onto a piece of wooden deck cargo and swam as far away from the ship as he could. The giant liner could sink at any moment, and when such a huge object goes down to the seabed, it forms a water funnel that pulls along everything around. Rescuers arrived at the scene sometime later. Fortunately, John Morris's pregnant wife and young son were alive, but his mother-in-law unfortunately didn't survive the disaster, like many other people that day. Of course, after this incident, the Greek Ministry of Merchant Marine initiated a thorough investigation. For 2 years, they collected information from passengers and the captain, studied the technical characteristics of the ship, and eventually came to certain conclusions. According to them, the ship's crew gave the evacuation order too late. Not all passengers were able to get into lifeboats, but half of those boats remained on board because of the chaos that prevailed during the evacuation. Several officers of the liner were accused of negligence, but the captain and his first mate received the most criticism. As for John Morris, he stated that he felt himself under protection that day. Another unusual story happened on a cruise ship relatively recently. Spoiler alert, the ship didn't sink, there was no evacuation, and the weather was good. However, for many passengers, this journey became a real challenge. Imagine that you've been working for a long time and saving up money to go on your dream trip on the Celebrity Mercury cruise ship in the Caribbean. You arrive in South Carolina, from where the ship begins its journey. You get on board, looking forward to a week's rest. At first, everything is fine. People are having fun, chefs are cooking delicious dishes, and beautiful daytime landscapes turn into night parties. But then suddenly, many passengers start throwing up. Someone is in a hurry to go to the toilet, and someone stays and vomits right in the halls. The cruise turns into chaos. More and more people feel terrible because of unknown poisoning. You also visited the restaurant and eaten seafood, but fortunately, the disease has avoided you, which can't be said for more than 400 other passengers. Almost every 1 in 4 people on board face gastrointestinal problems. There were almost 2,000 people, and a quarter of them are in bad condition. Crew members do endless cleaning. They wash the deck, give people nausea pills, and ask them not to leave the cabin till the illness passes. The captain sends several samples ashore to determine what caused the poisoning. Unfortunately, the cruise is already ruined, and all the passengers have unpleasant memories. So the company organizing the trip issues certificates that can be used on future cruises. It's not the most pleasant experience, but it's still better than nothing. Now, imagine if, instead of just feeling sick, people got infected with some kind of bacterium that would turn them into zombies. It would be much more exciting and scary. Now, do you think you could survive on such a ship full of zombies? And how would you do that? Tell me about it in the comments.
In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation. But sometimes, our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet, and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, it interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 25 miles per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time as long as centuries and millennia when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The Sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the Sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole, and vice versa. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth, since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth. And some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere. And these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years, and the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, This dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see any giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago, and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion, about 539 million years ago, might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's geomagnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current's negative charge, called electrons, move through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which otherwise would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever.
Imagine a giant, immensely powerful storm rotating over your head. You'd be terrified if you could see it. But this storm is invisible to the unaided eye. It isn't your regular hurricane. This intense phenomenon happens in space. Space hurricanes are giant swirling storms that form not in our oceans, but up in the ionosphere. It's part of Earth's upper atmosphere charged with energy from the sun. Space storms look a lot like traditional hurricanes, except they're made up of plasma, supercharged gases, and instead of raining water, they rain electrons. These massive rotating hurricanes appear over Earth's polar regions. Now, think of a space hurricane as a giant funnel or whirlpool of energy spiraling over the polar regions. It's only visible from high altitudes or by satellites. Space hurricanes also produce cyclone-like auroras. Such colorful light shows look similar to good old auroras, but there's a big twist. Space auroras usually spin near the North Pole for several hours, raining charged particles into the upper atmosphere. Hurricanes on Earth are born from warm ocean water and low-pressure areas. They're fueled by Earth's rotation and heat energy from the ocean. Space hurricanes, on the other hand, are created by a different process altogether. They're influenced by magnetic fields instead of Earth's water. When the solar wind, a steady flow of charged particles coming from the sun, comes into contact with Earth's magnetic field in just the right way, it creates a kind of swirling vortex of energy high up in the ionosphere. It starts spinning, much like how a regular hurricane spins in the atmosphere. Now, let's go all the way back to 2014. That was the first time researchers spotted a massive space storm over the Arctic using satellite data. That hurricane was huge, but at that time, they didn't know exactly what it was. What they did know was that its base stretched over 600 miles in diameter, and it had multiple spiral arms that looked just like the arms of a traditional hurricane. The storm also had a calm eye in the center. There, the plasma was still compared to the fast-rotating outer regions. Some parts of this storm spun at speeds up to 4,700 miles per hour. It's an incredible speed compared to Earth's hurricanes. The team observed the phenomenon for 8 hours. After that, it gradually broke down. Scientists managed to identify this storm as a space hurricane only in 2021, using observations that had been made several years before. Space hurricanes have several distinct features. First, it's cyclone-shaped, massive, bright auroras that can last for hours. Then there's the eye of the storm, a calm, stable center of the hurricane. A space hurricane also creates a circular magnetic field with strong disturbances around it. Plus, scientists mention electron rains in the ionosphere. These rains are what causes those bright, colorful auroras right below the storm. But how do space hurricanes form? To understand this process, we need to first talk about regular auroras, like the northern lights. The sun emits a stream of charged particles, also known as the solar wind, non-stop. And sometimes, this wind brings massive bursts of energy towards Earth. Luckily, Earth has a magnetic field that acts like a shield, protecting us from most of this high-energy solar radiation. But when solar winds are too strong, they can get into the upper atmosphere, especially near the poles. When these particles from the sun hit Earth's magnetic field, they release energy that lights up the sky in the form of auroras. Now, in a typical aurora, electrons from the solar wind excite nitrogen and oxygen molecules in the atmosphere, which then emit light, leading to colorful shows in the sky. Space hurricanes are similar, but they happen at higher latitudes, above the region where auroras usually appear. They create a swirling, cyclone-like effect that looks quite different. Scientists are still studying the exact conditions necessary for a space hurricane to occur. But they already know that, surprisingly, such storms happen during very calm space weather. This is the opposite of traditional geomagnetic storms, which need intense solar activity. Space hurricanes need just the right balance of low solar wind and northward-pointing magnetic fields. And even though these storms are uncommon, they aren't impossible, hence those unique swirling storms above the poles. When scientists observe the space hurricane over the North Pole, they notice some shocking similarities to hurricanes on Earth. Just like the typical hurricane, a space hurricane has a central area where the plasma is calm. Even more curiously, the plasma in space hurricanes spins in a counterclockwise direction, which is like hurricanes raging in the northern hemisphere. The space hurricane also has multiple spiral arms, just like the ones you can see in satellite images of Earth hurricanes. Plus, the space hurricane doesn't need the strong solar winds that typically create disturbances in our atmosphere. No, it forms in periods of calm, just like how an Earth hurricane can only form if the winds in the atmosphere aren't too disruptive. Now, space hurricanes may be high above us, but they can still affect our daily lives, especially in areas related to satellite communications and space navigation. Those electron rains caused by the storm interfere with radio signals that travel through the upper atmosphere. It can disrupt GPS systems, radio communications, and radar systems. What's even worse, this interference can impact the orbits of space debris or space junk, which is already a problem for spacecraft and satellites in low Earth orbit. The storm's electron rain slightly heats up the atmosphere, which leads to extra drag on satellites and can potentially change their orbits. At the same time, the effects space hurricanes have on Earth aren't as direct and disastrous as those of hurricanes down here. They really don't pose any serious health risks to astronauts or damage satellites. But researchers say that studying such storms can help improve predictions for satellite operations, especially for flights that cross polar regions. Now, interestingly, scientists didn't set out to find space hurricanes when they spotted one. The discovery was a total accident. It happened when Larry Lyons, a space physicist from UCLA, and his team were looking through satellite data for another study. In this study, they noticed unusually strong plasma flows in the polar cap, the region at Earth's poles where auroras usually don't appear. When they looked more closely, they saw that this plasma wasn't just flowing, it was swirling, creating a circular pattern with a bright auroral spot in the middle. The researchers were intrigued. They analyzed over 300 different space hurricane events that happened over a span of 11 years. These storms appeared most often in the afternoon during summer months. It made the scientists believe there might be certain times and conditions that could encourage their formation. Luckily, with new research tools and techniques, scientists have been able to identify space hurricanes with greater precision. And recently, they've spotted parallel storms happening near the South Pole as well. The most exciting thing about this research is that it might help us better understand Earth's space neighborhood and the way solar energy affects it. Scientists like Lyons believe that space hurricanes may not actually be a new phenomenon. They may have been occurring for a long time, but no one noticed them. Space plasma physicists point out that space hurricanes resemble a phenomenon people observed earlier. It's called high-latitude dayside auroras. At the same time, space hurricanes are much brighter, and they have stronger circular flows, which give them those hurricane-like arms. Understanding space hurricanes could eventually help scientists predict them. It would be useful for planning space missions and making satellites more reliable. Plus, by looking at these storms, researchers hope to create a more complete picture of how auroras behave at higher latitudes. And even though space hurricanes may seem purely like scientific curiosity, they can give us important clues about how Earth's magnetic field and atmosphere interact with the solar wind. And who knows? This understanding might even help us spot similar storms on other planets with magnetic fields. It could offer clues about magnetic storms beyond Earth. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities. In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the Sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the Sun are similar to this tousled hair. When the Sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the Sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the Sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the Sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere.
Whoosh! British astronomer Richard Carrington was observing the surface of the Sun through his telescope when he suddenly noticed something strange. There were two patches of very bright and white light. It's 1859. People are outside working on their farms, harvesting the fruits of their labor. Life is different, more nature, less technology. Science is developing. Not even a light bulb is invented yet. It will be invented in 20 years, though. Back then, the astronomer didn't know he was looking at what would later be called the Carrington Event, the largest solar storm ever recorded. In fact, this was the first solar flare we've ever seen and reported. And there was so much going on. Auroras, the southern and northern lights, were just amazing. They've been more intense in that year than in the last 160 years. Auroras mostly appear near the Earth's poles. But back then, you could see these perfectly illuminated lights in the sky close to both the equator and the poles. They spread across the sky from everywhere from Australia to Canada. If you happen to visit the tropics like Panama, Jamaica, or Cuba, you could also see auroras. It was spectacular. Luminous waves were rolling up as far as the zenith, and some were even big enough to cast a shadow on the ground. And the colorful displays were really bright. If you were in Missouri at that time, you could normally read a book by the atmospheric light even after midnight. The light was so strong that the gold miners that were in the Rocky Mountains just woke up, prepared their bacon and eggs, and made coffee without further questions. They thought the sun had risen on a cloudy morning, even though it was 1 a.m. local time. But this extremely strong solar outburst resulted in electrical disruptions from Boston to Paris too, and the telegraph lines. There was so much electricity in the air, telegraph machines could send messages from Pittsburgh to New York without batteries. In Paris, even sparks flew from telegraph machines. And now, fears are mounting that there's another powerful solar storm coming in 2025. It could cause massive power cuts and blackouts, as well as cut off internet access in entire communities, maybe even for months or years. Today, we depend on electricity way more than we did back then, not only when it comes to gadgets in our homes, but hospitals and other places where technology is simply necessary. Electricity is essential even for food, as we need electricity to store it. We need it for our everyday things like work and communication. Another solar storm as strong as the Carrington Event could cause trillions of dollars of damages here on Earth. It would knock out power for up to 40 million people only in the United States for a few years. What are solar flares anyway? They are the biggest explosive events that happen in our solar system. So, magnetic energy builds up in the sun. Bam! When there's an intense burst of that magnetic energy, that's when the solar outburst happens. This throws off whole waves of energy that move and travel outward. Of course, it impacts other bodies in our solar system, including the Earth. And when these electromagnetic waves interact with the magnetic field of our home planet, a few things happen. First, what we get is that electric currents flow in the upper layer of our atmosphere. They heat the air. It's like the Earth gets its own electric blanket. This is the stage where you can see stunning auroras over polar regions, but it's also when GPS and radio signals get disrupted. As our atmosphere heats, it puffs up, similar to a marshmallow. This adds more drag to satellites in low orbit. It means that as the atmosphere expands, it's pushing satellites back down to the surface of our planet. It also knocks small pieces of space junk off their course. As strong electric currents flow through the Earth's upper atmosphere, they affect strong currents that flow through our planet's crust too. This can mess with electrical conductors that sit on top of the crust, like power grids. They make the network that carries electricity from generating stations to buildings and homes. And this results in power outages in certain areas, and this can be hard to fix. For instance, this happened in Quebec in March 1989. A powerful solar flare burst off the sun. Shortly after that, another burst sent out 1 billion tons of gas directly to our planet. People there experienced a 12-hour blackout. Only a couple of months later, in August, another solar flare burst towards our planet. It was even bigger than the one that occurred in March. It caused damage to microchips across the world and left Quebec in darkness once again. Flares can be more dangerous for the technology we have than for ourselves. In winter 2022, a solar storm knocked a fleet of over 40 Starlink mini-satellites out of orbit. Solar storms often happen at the same time when the sun releases large bubbles of solar material we know as CMEs, or coronal mass ejections. These bubbles can have billions of tons of plasma, which can move at millions of miles per hour. That way, solar storms fire out radiation, whereas CMEs are plasma eruptions. CMEs and solar flares discharge particles and radiation. As they hit the upper part of Earth's atmosphere, they form radio waves. We call them geomagnetic storms. They form new currents and add energy into electrical grids that are usually passive. This way, they threaten to overload them. Take electricity that's coming out of your wall plug as an example. It changes back and forth by about 50 Hz, depending on the country you live in. Radio waves usually broadcast about 85 to 105 million Hz. Gamma rays and X-rays have frequencies of up to 50 quintillion Hz. Solar radiation is the same one your phone uses for power, only a couple billion times stronger and kinda out of control. Researchers believe a powerful solar storm might hit us in 2025. These storms get to their peak, which, by the way, can turn pretty violent, every 11 years. We mostly get lucky because they bypass us, but we can't expect our good fortune to last forever. Now, we have about a 2 to 3% chance for a Carrington-level event to happen in this decade. The shorted electrical grid wouldn't be only a one-time loss. It would take us up to 10 years to recover from something like that. That way, humankind might be set back by nearly 20 years if it happens. All those particles wildly bursting around could cause damage to our satellites. We could lose communications that way. No TV, internet, or GPS. We'd be dealing with very, very strong radiation. There's a possibility people would face some long-term issues because of that. What could such an amount of solar radiation do to our DNA? Especially those that are not protected by the magnetic field of our planet, like astronauts. Humankind can try to protect the internet against the next enormous solar storm. The first thing we can do is to shore up power grids, undersea cables, and satellites against being overloaded. And we can look for methods of predicting such storms in the long run. That's hard because these storms have been happening for millions of years and we've been able to record them for less than a century. Plus, the technology these storms affect is only 2 decades old. At the moment, we can observe the activity of sunspots, which are black patches on the solar surface that tell us it's the area with high plasma activity. And by checking them, we can predict solar storms up to 2 days before they strike our planet. But we can't track them the way we follow hurricanes. Hopefully, we'll be more ready by 2025 to avoid an internetless future. Although, it would be cool to take a break from social media, don't you think?